Good morning. Thank you, everyone, for the wonderful talk. And my name is Sam Hamilton. I'm with PayPal. And I'm going to be talking about a little bit, 30 seconds on the PayPal, then to a little bit of the topic that we are going to be introducing. And PayPal is 143 plus million active, very active wallets in the cloud, managed by the global platform with great relationship and data about the consumers. We specialize in risk and security of those wallets in the cloud. And we're talking about big data. I don't think I need to talk about the value of data. And there may be definitions of what is big data is. We'll get to that part of the discussion. But what I got to tell you is some of the things has not changed. The value that we get from the data and the process that we use and also the core things that we have in place has not changed over a period of time. But I believe that needs a transformation now. The transformation in 4 different dimensions, if you would. That's what, who, when, and how. When it comes to a what, it's not just processing the transactions anymore. It's a processing of the data that we get from the transaction, processing from the data from the jet engines, processing the data from your Fitbit, whole bunch of things that is coming in. That talks about the volume, velocity, and variety of data that we have to process. And when we talk about who, it's not the business decision makers or the analysts in the organization, which was 15, 20 years ago. Now, the demanding consumer, customers. Look at this. In the past, once a month, probably, we looked at the data and looked at the report and made the decision. Now, the expectation is consumer wants to know what they have done based on that, a recommendation to what to buy for your mom for her birthday, all the way to the transaction that you have done on such a category in the last 15 days, all the things in between. When I talk about the when, the latency is not, as I said, it's not a once a month. It's instantaneous, real time. It has to be saving the lives of the people. Can't wait for 3 days and 4 days and 5 days to get the data on. And talk about how. The how, the things are the same. And we talk about acquiring, transforming, finding, exploring, and using and testing. But good news is that with all the things that, all the dimension that is changing, there's a huge change in the industry from open source to the small companies and large companies and enterprises and startups are into this business of helping to build this analytical stack. And during the course of time, that we will be talking about what are such tools and what we have in your tool house and around you to build that analytical stack that you need.
My name is Maciek Krenz. I run the corporate technology group at Cisco. And to build up actually on Evren's talk, in addition to big data or smart data, I actually don't like the terms big data, but we can argue about it later. We also seeing a huge growth in the number of data sources. Currently, we have around 10 billion devices connected to the networks. And over the next 7 years, by the year 2020, as Evren said, it was great to see that we are talking about the same numbers. We'll have 50 billion devices connected to the network. In the next 3 or 4 years, every car that we'll be driving, new car we're driving, will be connected to the networks. Every truck, every train, bridges, buildings, and so forth. And the interesting thing is that when you talk to customers and in this connected world, they're starting to see new use cases and new business cases being developed around real time, around scale, when you're running tens of thousands of trucks and you're monitoring them for preventive maintenance. When you think about the number or the amount of data being generated, when you think about the oil rig, today oil rig generates around 20 terabits of data per minute, all the sensors around it. With fiber sensing, will be around 100 terabits of data per minute. But the point of all of this is that we are starting a huge innovation cycle and also a huge business opportunity. Evren, you talked about just a 1% of improvement in productivity. We'll talk later about examples when you actually see double or triple the improvements in productivity, and the impact on the economy over the next 10 years, we estimate, will be a staggering $19 trillion across the use cases, across the different domains and geographies.
there's a lot of hype regarding the new architecture of databases. So I'm going to try to explain some of these differences between which should I choose. We have relational database, we have NoSQL, we have NewSQL, and many of these have many variants. One thing that I think is very important to say is that no solution fits all. And in one side, we have relational databases that are still a very good general purpose databases, and that works for majority of the problems that a lot of the organizations have. Relational databases comply with something called ACID. ACID stands for atomacy, consistency, isolation, and durability. And what basically this is if you go to a bank and you deposit a check, even if the system goes down exactly at the same time that you commit the transaction, you will still have the money in the bank. That's something that we take for granted because we have had this for the last 30 years. Some of these, the new architects, like a lot of the new NoSQL, works very well for a lot of amount of data, but they don't support ACID. And one of the mistakes that I've seen is people are trying to use some of these new architectures for things like transactions, when in reality they're not very good. So if your bank tells you tomorrow that they should change to a non-ACID compliant database, I would recommend you to move to a different bank. However, in the case of NoSQL, they are an excellent platform because they don't need to pay these, what I call the ACID tax. They are an excellent platform that will scale better and will perform better, but they just need to be used for the right problem. Then you have NewSQL. NewSQL tries to be somehow in the middle, and basically by removing some of the restrictions of ACID, still make it ACID compliant. There's still a long way to go. I think that it's still a very new technology, but I think that that's hopefully where these platforms are going to move.
Thank you, everybody, for being here and listening, and thank you for the opportunity here. I'm not a technologist, not like Microsoft, Cisco, or Google. I feel, a little bit out of place almost. I'm from healthcare. I'm from a small company or medium-sized company, 700 people. I'm also from a bigger company that has 130,000 people at the same time. So I'm a little bit schizophrenic, and I apologize for that in advance. But I think, for us, looking at big data, I'm a user, I'm a consumer of big data. I want to be able to do more with it. And how do we roll it out was really one of the things we wanted to look at. What are the things that we need to concentrate on and figure it out? So, one of the things that's obvious is, big data's got to eliminate some of the constraints for us in and around the storage. And that means that, you got to bring paradigms and tools that will not limit you to your NetApp's storage system in your data center. We need to eliminate the barriers also for the users. Whatever that means, our users have to be empowered. We can't rely on too many specialists to do all the work for them. And then I think one of the key things when we look at things is it's got to provide a synergy or a direct interface or a direct path to integration with your traditional BI data, your traditional enterprise data. If you're going to use that to drive the business, it's got to match the rest of the enterprise. So that's there. And finally, it has to come with a complete suite of solutions. So that's what we looked at. Obviously, one, you select the data store. There's plenty of solutions out there. Two is you align then your data integration solutions to that. And one of the things that we got worried and we got hit by a little bit when we were working on this is you got to be careful about, going forward about the cost of maintaining that whole environment and how much manual things you end up doing on a daily basis that really take away. So you apply that and you say, okay, well, what does it look like in healthcare? And healthcare, just like everyone told us, it's huge. There's huge opportunities. It's also probably one of the most fragmented environments out there from a data point of view, from a data silo, from a data fragmentation. So we have on one side incredible technologies driving data capture, and where sometimes the data quality is in question because it's, let's face it, entered by humans, and therefore it's not necessarily accurate to the level where you can rely on it 100%. And then you have that dispersed all over various environments, whether it's your mobile device, on a home care device, on the web, if it's a public database of genome data. So there's a whole slew of things there that you get to deal with. And one of the things you have to extract is value-added services, where you can provide value to your own business and provide value for us to the patient. So that's one of the things there. One of the biggest challenges we've ran into was, for lack of a better term, reliable, sticky interfaces, which is if you rely on being able to pull data from a certain location or a certain store, if you want to call it that, it's got to be there tomorrow, and it's got to be there 6 months from now. And that leads to the question, do we need standards, or is it still a taboo word for some of the things there? So.
Good morning, William Vabenep. I lead the PM team in Google Cloud Platform, responsible for big data services on the cloud platform. And in a couple of minutes, I just want to maybe pick one area and one way to make big data useful, specifically graph analysis. When you start to collect, analyze very large amounts of data, pretty quickly you realize that there are some patterns and some shapes of data that repeat themselves. One of the most useful and interesting ones is when the data can be modeled as a graph, which means sets of nodes or vertices representing things, people, objects, and edges or links between them, such as Marie Curie as a person and Warsaw as a city being the place of her birth, being the relationship between them. And so in many cases, you can model your data that way. For example, when Google started as a search engine, really what gave it its initial success was the realization that the web itself can be modeled as a graph, and that web search and ranking of results can be informed by the relationship between the pages instead of focusing just on the content of each page. And that's one example. More recently, things like social networks are an obvious example of a domain where a graph-like structure is useful. Or as described here, the knowledge graph, which is how Google tries to turn data into information such that instead of just finding pages, it can actually answer questions. That is also powered by a huge graph of data points that can be mined. In other areas, in many other areas, graph structure exists, even though sometimes they're harder to find. So if you're talking about transportation networks or computer networks, it's pretty clear how those are graph problems. But there are many other, in business analysis, in disease propagation, some chemical structures can be, if you squint, modeled as a graph. And the reason why you want to take a look at that and see whether that's the right approach for your problem is that over the last 10 years, we've made a lot of progress in developing tools to efficiently analyze graphs at very large scale. So internally at Google, we have a tool called Pregel, which can analyze graphs with billions and billions of edges and nodes, and it makes it very easy to program and to think about graph analysis, and much more efficient than general purpose parallel processing techniques such as MapReduce. So some more tools are available now in the industry at large, many of them based on Pregel, which has been published as an academic paper. And so as a result of this, it's really important when you're dealing with large data to not jump to kind of the brute force analysis method, but really think through the structure of the data such that you can use the right tool for the job, which in some cases may well be graph analysis. Thank you.